Hello, my name is Ryan Fleming, and today we will be discussing the unit circle, the bane of a trigonometry student's existence. It's a looming evil that will someday have to be memorized, but fear not, because by the end of this video, you will have the unit circle completely memorized. It's a common practice among educators to force their students to fully memorize the unit circle, and that's for good reason. Having this information stored in your head is extremely helpful moving forward in mathematics. It's something that you'll need to recall constantly in trigonometry and in calculus. The unit circle, although fairly daunting when you first look at it, is actually fairly easy to memorize and understand when it's explained correctly. In my personal experience tutoring trigonometry, which is the subject that the unit circle's first learned in, I have found a great trick to remember it. So, by the end of this video, hopefully you will understand how to fully recreate the unit circle from memory. So, what is the unit circle, and what does it mean in terms of trigonometry? MathWorld describes the unit circle as a circle of unit radius, i.e. of radius 1. It's used as the basis of the trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent. The unit circle that you memorize only requires you to remember the values of sine and cosine, so that's all we'll be talking about today. Alright, let's take a look at a 30-degree angle on the circle. There's a point here on the edge of the circle that was just defined by the angle we provided. So let's get rid of the circle and just look at this point. Now, we want to know the x and y values of this point on the coordinate plane. For now, I'm just going to tell you what they are, but you will know how I got these soon. The x value here is root 3 over 2, and the y value is 1/2. Okay, now let's bring back the circle. We can see here that this angle of 30 degrees defined a point. From that point, we found x and y values from it, and here's the cool thing. The y value of this point is the sine of 30 degrees, and the x value of the point is the cosine of 30 degrees. So from any angle on the entire unit circle, we can find out sine and cosine. So the unit circle that we memorized defines 16 different significant angles. So what are all these important angles that we need to memorize? They're all actually simple divisions of the circle. And as your teacher might have specified, each one needs to be memorized in degrees and radians. Let's start with this initial angle here. Lucky for you, it's 0 in both degrees and radians. Okay, great, that one's easy. Unfortunately, this is where radians and degrees deviate. Degree measure in a circle adds up to a total of 360 degrees, so each of these quadrants is a total of 90 degrees. An easy way to think of degrees is to use addition to find out what the measure is. So this next one here would be 90 plus 90, which is 180 degrees and so on. Okay, as for radian measure, the total circle adds up to 2 pi. Because of that, we know that this angle here would be pi because it's at the halfway point. This angle here is between 0 and pi, so we can call that pi over 2, or pi halves, I guess. And this one is between pi and 2 pi, which would be 3 pi over 2. Keep in mind that the unit circle uses improper fractions and never mixed fractions. I think it's really helpful to think of radians more as fractions rather than in terms of degree measure. These top 2 quadrants add up to pi, so one of the quadrants will have the value of half of pi. That's just a good way that I've found to think of it. Okay, now we'll split the circle again across the middle of the quadrants. In degrees, each of these quadrants is 90, and that means that this angle in the middle must be 45 degrees, which is half of 90. Using this information, we can use each following quadrantial angle, like the main ones that we just figured out, to find every value. So 90 plus 45, 135, 180 plus 45, 225 degrees, 270 plus 45 is 315 degrees. Okay, so in radians, these are each half of a quadrant, and we know that one quadrant is pi over 2 radians. So this first angle is pi over 4 radians, because it's half. And then this angle here is 3/4 of the way through the top quadrant, which is the way I like to think of it. So I write that as 3 pi over 4. You can also think of that as adding pi over 4 to pi over 2, which would give the same answer. Okay, now we can do this for the 2 remaining angles. This one here is pi over 4 past pi, so its value is 5 pi over 4. For this last one, I usually like to think of it as 2 pi minus pi over 4, because it's easy to visualize, so that one is 7 pi over 4. Okay, now we just need to draw 2 more sets of lines here and here. Keep in mind that these lines are not halfway in between, but we'll get to that. Okay, These next lines are a tad more difficult, but let's look at degrees first. This first line here is 1/3 of the first quadrant, which is 30 degrees, and we know that because of 90 divided by 3. And then this next one is 2/3 of the first quadrant, which would be 60 degrees. You can also think of this one as double 30 degrees. Okay, so now we continue through the quadrants, adding 30 degrees and then 60 degrees to each of the quadrantal angles. Okay, great. Now these radian measures can be thought of in a lot of ways, and it really comes down to personal preference. The first one here is 1/3 of the first quadrant, which would be pi over 6, and with that knowledge we can determine the next one by doubling pi over 6 to find pi over 3. You can think of this angle as 1/3 of the top two quadrants, so then the next one would be 2/3 of the top two quadrants, so 2 pi over 3. And this one here, I like to think of it as pi minus pi over 6, which would give 5 pi over 6. And you can think of the following ones in the same way. But really, when it comes down to it, it's all about memorizing patterns. Alright, now that we have those angle measures in our head, let's look at the actual points. Many people actually think that the coordinate points are the most difficult part of the unit circle, but I have to disagree. These values can all actually be memorized based on a few very simple ideas. 4 of these points are very easy. The radius of the circle is 1, so the coordinates of this point would be 1, 0. The next one would be 0, 1, because it goes in the y-axis. The next one would be -1, 0. It goes in the negative x-axis, but y is still 0. The final one is 0, -1, because the y-axis is negative. Okay, just think of the whole circle as being on a coordinate plane, like the ones that you used in algebra and geometry. Now let's focus on the first quadrant. There are 3 coordinate pairs that we need to find. You can see that on these 3 lines. So let's start with the x values. From left to right, write 1, 2, 3 correlated with each point. Now do the same for the y value from the bottom to top. 1, 2, 3. You should have the following coordinates, but we know this is wrong because the radius of the circle is 1, and we can't have 3 at one of these points. So divide all of these points by 2, so now they look like this. But this is still wrong. Why? Because 3/2 is greater than 1. So that's a good way to remember that you have to square root all the numerators. Also, side note, remember that the square root of 1 is 1, so you don't need to write that one. In my opinion, this is the best way to remember, or I guess, create all of the points on the unit circle. Make sure you remember that none of these points can ever be greater than 1. But wait, there's still 3 whole other quadrants for us to do. Well, lucky you, these coordinate pairs are just used in all of the other quadrants with different signs. Quadrant 2, x is negative and y is positive. Quadrant 3, both x and y are negative. Quadrant 4, x is positive and y is negative. This is a great way to be able to write down all of these from memory. It can be difficult at first, so don't feel bad if that was a lot to take in. Just remember the strategy to make each x and y coordinate. Congrats, you made it through. So, as we set out to do in the beginning, we have covered how to memorize the entire unit circle. What I hope that you trig students take from this video is what the unit circle is, what it's used for, and how you can recreate it. Remember that radian measure is like a group of fractions, and that you can use the counting trick to create all the points in a unit circle. I hope that this video was helpful in allowing you to have a better understanding of the unit circle, and I hope it helps you in your future mathematics. Thank you.